everybody. A student has asked about a couple of questions in the problem solving file about payoff matrices. So let's go through them very, very briefly. So we're dealing here with a case of two companies. So it's a duopoly. We've got Megabox and Humungobox, and they're cardboard box manufacturers. And we're trying to figure out how they're going to behave. Each of them has possible strategies of charging high prices or low prices. So let's see what kind of outcomes we've got. A way to try and think about this is to imagine yourself as the player on the left-hand side. So in this case, we'll say your Megabox. So if you're Megabox, you have to think to yourself, okay, what's Humungobox going to do? Are they going to charge a high price or are they going to charge a low price? Well, I don't know for sure. Let's work through it. So we say to ourselves, if Humungobox were to charge a high price, what should I do? Should I charge a high price as well and make $50 million? Or should I charge a low price and make $60 million? 60 million better than 50 million, so I will charge a low price if Humungo were to charge a high price. And then I think to myself, what if, on the other hand, they were to choose a low price? What should I do then? Should I choose a high price and make zero profit, or should I choose a low price and make $10 million profit? 10 million better than nothing. So in that case, I'll choose to charge a low price. And then we realize, hang on a sec, no matter what Humungobox does, I'm always going to charge a low price. That is to say, the low price strategy is my dominant strategy. I'm always going to choose that. Now, after we've done that, then put yourself into the shoes of the Humungobox CEO. Now, the Humungobox CEO is not a moron. They themselves have gone through the very thought process that we ourselves have gone through. And they've deduced that Megabox has a dominant strategy. And their dominant strategy is to charge a low price no matter what. So I know that, as the CEO of Humungobox, I know that. Megabox is always going to go low. In that case, what should I do? Should I charge a high price and make zero profit? Or should I charge a low price and make $10 million profit? I'm going to go for 10 million, better than nothing. But that means I will be charging a low price. Megabox will be charging a low price. It's their dominant strategy. So we're going to end up with an equilibrium point in this cell here, 10-10, both charging low prices. This is a Nash equilibrium. Okay? Happy with that scenario? Furthermore, we can say in this simple one-shot game or one-round game that it is the only Nash equilibrium. Why? Because in any other cell, any other combination of strategies, there is an incentive on the part of one of the parties to shift, to switch to an alternative strategy. Okay? That's true, and you can check that for yourself. I'll just give you a quick example. Say, for example, that both Megabox and Humungobox, for some reason or other, happen to choose high price. So they're both making $50 million. You say, oh, that's pretty good. That's fantastic. Why is it not a Nash equilibrium? It's not a Nash equilibrium because Megabox has an incentive to shift from high price to low price. They're making $50 million, yes. But if they shifted to low price, then they'd make 60 million. So by shifting, they can get a better deal, a better outcome, right? If there's something better on offer than where you're at now, which will provide an incentive to shift, then that where you are now is not a Nash equilibrium, okay? And by the way, it's exactly the same because it's all symmetrical. It's exactly the same reasoning for Humungo Box, making 50, but if they charged a lower price, they could make 60. So they have an incentive to move this way, okay? To move away from the higher price sell, okay? That's why it's not an equilibrium. All right, that's that. Let's go to the next one. All right, let's have a look. We got our Mega Box and Humungo Box again. And this time, the two strategies that are on offer are cutting advertising and raising prices. So these are possible strategies that could be employed, presumably, for firms to make profit. So you can cut advertising and thereby cut your costs, let's say. Or you can raise prices in the hope that consumers will stay with you and you have to charge they have to pay higher prices. All right. So, again, think of yourself, start by thinking of yourself as Megabox. Right? And then you say, okay, if Humungo Box, my potential enemy, were to cut their advertising, what should I do? Should I cut my advertising as well and make $50 million? Or should I raise my prices and make nothing? $50 million is better, so I'm going to cut my advertising. If Humungo Box cuts advertising, I'm going to cut advertising. What if, on the other hand, Humungo Box were to choose to raise their prices? What should I do then? Should I cut my advertising, as before, and make zero profit? Or should I raise my prices and make $20 million profit? 20 million is better than nothing, so I'll raise my prices in that case. So, all right, so this is clearly different to the previous scenario because now Megabox's decision to cut advertising or raise prices depends upon what they think Humungo Box is going to do. It's not the case that Megabox has a dominant strategy anymore. Okay. The strategy they choose will depend on what they believe the other person's going to do. And it's equally true because the whole thing is symmetrical. The matrix is symmetrical. It's equally true for Humungo Box. They're in exactly the same situation. So where do they end up? Well, in order to answer that question, in a sense we need to add a bit more detail to this game. We might say that, well, whichever party goes first will effectively dictate where they end up. So let's say you get to go first, so to speak. So you can choose to either cut your advertising, right, and make $50 million because you know Humungo Box is going to copy. Right? We've already established they've got a tit-for-tat problem here, or a copy problem. So if you cut your advertising to make $50 million, you know they're going to do the same. Or you can raise your prices, and they'll raise their prices, and you'll make $20 million. Which would you rather have? 20 million by raising your prices, and they'll follow suit, or cut your advertising, and they'll follow suit, you make 50 million. 50 million better than 20, so you'll choose, if you get to go first, you'll choose cut advertising, knowing that Humungo Box is going to follow suit. All right, that's preferable. Okie doke. And if on the other hand Humungo Box were to go first, I'll let you figure it out for yourself, but if Humungo Box were to go first, then they would prefer to raise prices, make 50 million, rather than cut their advertising and make 20. Okay. So it depends on who goes first as to where they end up. If Megabox goes first, they'll end up in this top cell here. They'll both cut advertising. If Humongo Box goes first, then they'll end up both cutting prices. They'll be down here. And furthermore, once they end up either in this cell here, the cut advertising cell, or raise prices cell, once they're in either one, there is no incentive for either party to switch to an alternative strategy. Okay? In which case, we can say that the cut advertising cell is a Nash equilibrium, but also the raise prices cell is a Nash equilibrium. So in this case, unlike the previous case, we've got multiple equilibria. There's more than one Nash equilibrium in this case. Okie doke, that's that.